On this part of chemistry, we are going to talk about mixtures. What are mixtures and what are the characteristics or the classifications of mixtures, and what's the difference between mixtures and compounds in chemistry? And when we say for a group of elements or compounds, when we call it compound and when do we call it mixture? Okay, mixture in general, it's two elements or more, or two components or more that are combined but not chemically. How? For example, now I have a dish of salad that it has tomatoes, pepper, carrots, and so on. These ones now are a group of components in one place, but they are not chemically reacted. So these ones we call them mixtures. Like when I have water and inside it sugar. This one is a solution. I mean, it is a mixture and it is not also a compound. Okay, what's the difference between compound and mixtures? Compound in chemistry is two elements or more. They reacted chemically to produce a new substance. So for example, now if I have Na plus Cl, this one is sodium and this one is chlorine. When they react together, they give us, or they produce new material, which is what? NaCl. So new substance, which is what? NaCl. So in this case now, compound is two or more elements. They react chemically and they produce new substance. And this new substance now, it's hard for you to move it back to their originals. It's hard for you to distribute the sodium and the chlorine again to change it to their originals. So this one we call it compound. But mixtures now, like here, for example, when you have sugar inside water, you stir them, so that means it's hard for you to distinguish the sugar or the salt inside the water. It's hard for you to distinguish the particles, but you can easily, separate them back to their originals. That means if you heat now this solution or this mixture, water will evaporate and other material will remain there. So that means now you can split them back to their originals. So mixtures are it's easy for you to split them to their, or to separate them to their original components, while compounds you can't. It's hard. Not you can't, but it has chemical way to move them back as they are. So two classifications also of mixtures. One of them is called homogeneous mixtures, and one of them is called what? Heterogeneous mixtures. And homogeneous mixtures are the mixtures that it's hard for you to distinguish between their components. How? Now when we put sugar inside the water and we stir them, when we see them, this solution or this mixture, it's hard for you to distinguish the sugar particles from the water particles. So in this case now, or molecules. So in this case, we call this mixture what? Homogeneous. So it's hard for you to distinguish between the components. But in hetero, you can distinguish between what? The components. Like when I have sand in water, I can distinguish the particles from the components of sand and the components of water. I can see it by using my eye. So this one is called heterogeneous what? Mixture. Okay, so this one is hard for you to distinguish, and it is like sugar inside what? Inside water. But here now, in heterogeneous, we have mainly two classifications. We have colloid and we have what? Suspension. Mainly we have these ones here that are related to what we are going to study. So colloid, mainly it's milk and blood. How? So blood and milk, can put that in your mind, they are colloid. That means they are heterogeneous mixtures, not homogeneous. Yes, we see, okay, why? Because milk, I cannot distinguish the particles, but really you can distinguish by using Tyndall effect or by using other things. That means you can understand that this is what? Heterogeneous mixtures. Okay, while suspension is like when you put sand inside the water, so that means you can see one material is suspended So in this case, either like oil with water or sand with water. This one you call it suspension, heterogeneous mixture. While colloid like milk and blood, we call them what? Colloids, and you call them heterogeneous mixtures. Okay, inhomogeneous. Now, if we go to the other part here, which is homogeneous mixtures, we said it is hard for you to distinguish between the components, like sugar inside water. Okay, sugar and water now, when they are homogeneous mixtures, we can call them what? We can call them solutions. We can call homogeneous mixture, we can call it what? Solutions. Okay, what are solutions now? They are homogeneous mixtures. Good. And what do we need to know about solutions? Solutions, they contain two or more components. Okay, and they for example, in this case, if we are talking about sugar and water, as we know, the water molecules are much more than the sugar molecules. The amount of water is more than the amount of sugar in the solution. So we call the higher amount, which is water, we call it what? Solvent. We call it solvent, while the sugar here, we call it what? Solute. So that means solutions, it contains solute and it contains what? Solvent. The big amount or the greater amount is solvent and the less amount is what? Is solute. And in general solutions, you cannot distinguish between what? Their components. Okay, solutions, can they be only for liquids? No, they can be gas, liquid, gas. How? For example, here in seawater, as we know, water is liquid and it has or it contains particles of or components of salts, and these salts are solid. So we call the seawater, we call it liquid gas solution. Okay, what about if I have an alloy that contains like iron and carbon, for example, both of them solid? In this case, we call this alloy, since it's hard for you to distinguish its components, we call this alloy solid solution. Solid, and so it contains two materials that they are what? Solid. So that means you call it solid what? Solution. And we have other solutions like gas. If we have two gases together, they make in a container. One of them we call it solvent, one solute. This one we call it what? Solution, gas solution. So you have gas solution, gas, solid, liquid, and so on. So these ones are solutions, and they are mainly homogeneous mixtures. Okay, we need to know just more 2 points about mixtures. Here, if we have here water in a container, in a transparent container, and you have here also transparent container that it has what? Milk. So this one is milk, and this one is what? Is water. If we scatter light, if we put here straight, like light that goes in a straight line, we're gonna see this light here on the water. Usually it goes in a straight line, so we see here like a spot in the other side. But for the milk, you're gonna see the light that is it is scattered. It is scattered throughout all the container. So this one here, we can say that in the milk there are more solute inside the solvent. More solute are in the solvent. So this effect now is called Tyndall effect, and it is concentrating in how the light is scattered when it goes through a solution. Okay, we have another thing which is called Brownian motion. What is Brownian motion? If we have here, sometimes this one is a solution, and sometimes we put here a small particle solid. And usually if you concentrate more, like if you have juice and you concentrate more into inside that juice, you're gonna see small particles of orange or whatever, small particles that they are keep moving left, right, up, down, and they don't precipitate at the bottom of what? of the container. So this movement now of these particles of solute inside the solution, we call it Brownian motion. And Brownian motion now, it prevents the solute particles from precipitating what? On the bottom of the container. This one is also Brownian motion is called, and it is named after a scientist whose name is Brown that discovered this one. That's for this part. Next part, which is related to solutions and concentrations and other things, will be for the next video.